clear and my screen is visible? Just write down in the chat. Anyone please write down in the chat whether my voice is clear and screen is visible? Yes. So we will start at 10:35. So I will wait 4 minutes. Okay. And today's lecture session will be, I will start with the Plotline Library. That is similar to this Matplotlib and Seaborn, but it is an implementation of Ggplot 2 that is available in R programming language developed by Hartley Wickham. In the second session, it will be for hypothesis testing, like different types of tests. Like we do the t-test, paired t-test, then ANOVA, one-way ANOVA, two-way ANOVA, then correlation plots, categorical correlation plots, and estimating those correlations using Python, SciPy library. That will be from, I guess, second session. If we are able to complete this in 1 hour, then we'll start that after 15 minutes. If Google Drive, there is a problem, then I have also uploaded that in Teams files folder. You can go the lecture session, day 6 is available there. You can download the, you don't have to download the data sets because it is same, just download the IPython notebooks. There are 3 notebooks. Okay, it is 10:35. Then I will start the session. I hope I'm audible and my screen is visible to all. So this session is for Plotline. Plotline is a library for plotting. Actually, it is a implementation of the Ggplot2 library that is available in R programming language. So it is the R programming language. It is known as Ggplot2. It is developed by Hartley Wickham. He is a principal scientist in RStudio INC, and the same has been implemented in Python, and it is known right now as Plotline. And there are other libraries are also there, like Plotly, that I will show at the end, 1 or 2 graphs. That is a JavaScript-based plotting library. That is an interactive library. Okay, not a static plot, it's a dynamic plot. And in next session, I will show some part of the stats models and SciPy. But here I will use the SciPy library for plotting the Ggplot. That is a quantile plot. We usually use it to confirm whether the data is normal or not. And stats model is a library that is used for hypothesis testing, plus any type of statistical models like linear regression, multiple linear regression, logistic regression, multinomial logistic regression, ordered logistic regression, then quantile regressions, non-parametric regressions, and even time series analysis can be done using a stats model library. Okay, like ARIMA models and auto-regressive moving average and SERIMA models like seasonal ARIMA type models that can be also done with stats models. So you can look at the stats models documentation if you would like after the session. And the content of this session will be line plot using this Plotline library, dot plot, stacked bar plot, scatter plot, histogram, density plot, box plot, linear regression plot, Ggplot. And that would be very easy to plot with this library because it doesn't require any formatting of the data set. Directly, you can take a data frame, read using pandas, and directly you can plot whatever the plot you want. Then at the end, I will show interactive plot histogram using the Plotly and interactive box and VSUM plot together with Plotly. Okay, so those who have already created this data science environment, to install the library Plotline, either you can use the pip install Plotline or you can use the conda install -c, that is the channel conda forge Plotline. Okay, both will work. Either you can use the terminal, new terminal, and here you can activate here is already activated the data science. Here you can directly type pip or the conda version. Both will work. Or otherwise, you can go to the start menu and look for the Anaconda prompt and then activate the environment and install. This process is same for installing any library. So I have already installed. For this session, we need the NumPy library. So I have imported as NP, that is the nickname, then pandas as PD, then imported the Plotline, and also from Plotline imported the star. That's mean import every module. Okay. So Plotline also has a default configuration for figure. Like in Matplotlib, we have to define every time the figure size. But here you can, before starting the session for Plotline plotting, you can directly define a global size so that whatever the plot will create, it will create with the same size. So Plotline dot options dot figure size equal to with tuple 7.5 and 4.2. That is in inches. Okay, and if you run that, it will take some time because Plotline library is a little bit big, and it's done. So next is line plot. For line plot, I will use the copper.csv. This is a data set for import export, and this let me clear the output. Okay, so that it will be clear. So it is a data set. The products like copper and two things are there: years and export, the percentage of export, and sum. It is in tons or some other unit. So let's say we first go for the information, what it contains actually. So copper.info, we have read it using the read underscore CSV. Okay, so it is a CSV file. And then copper.info, it will provide the information of the data set. Like product, it's a like string values are there. So it is a object data type, and rest are integer 64 because they are numeric integer values. And let's say what this product actually contains. So we can either use the value count to see how many this product contains. So copper, you can use the dot log. You can also use that. That is not an issue. Dot log, and then square bracket, all the rows and column is product. And then you apply the value count. That will also work. So no issue. Okay, so it contains two types of, one is copper and other is other export. So that's why it's a copper data set, because it's specifically mentioned the copper part. And we would like to plot this, say over the year, what is the export? I would like to plot this in x-axis the year, and over the year, what is the export? Okay, so I would like to plot that. And how would I do that? And that I want to plot as a line plot. Okay, so Ggplot2 is specially known as grammar of graphics because it has a syntax like grammar, one after another, like subject, verb, and the object like this. So first we have to define with Ggplot. First we have to define the data set. Data set here is copper. Okay, copper. Data set is copper. Then we have to provide the mapping. Mapping means what will be in a blank canvas, what will be your x-axis, what you want to map in x-axis, what you want to map in y-axis, what would be the fill color, like this. So mapping equal to, then you have to give the aesthetics. What are the aesthetics of that plot will be? What would be the x object? What would be the y object? So let's say x equal to year and y, say in y we were to give the export column. Okay, that is done. And after that, what it will create a blank plot. Okay, so let me check this whether it's create a blank plot or not. So in square bracket, it will treat it as a one object. If you plot, it is showing that blank object. Okay, so that means in x-axis here, in y-axis exports. But to give something to that plot, we have to give some geometric, like a point or line or something. So in ggplot2, it is called geom, so geometry. So let's say I would like to add a line. Okay, so with here plus sign, next in next layer over that plot, I want to put points or line, whatever you want, say line. So geom underscore, automatically it will highlight, okay, in VS Code, line. So geom underscore line, it is there. So you can directly type or tab, it will line and square bracket, that is a function. And if I enter, now it shows that it is showing the lines. Okay, for over the year, it connected the different points because the data set contains only how many values? 18 entries. Okay, so it is a line plot. But let's say after line, giving the line, okay, what you have plotted this one. But I would like to add, say, points on that in rather than with what it called. We have called it in matplotlib, I guess, that point part. I can't remember right now. Marker. Okay. So if you would like to add the marker where the points are, where the values are, you can directly use geom underscore point, next layer over that, and size will be 2, color will be blue. And here the in geom underscore line, the line size is, line width is 1.5. Okay, that way it is layer by layer. It will, you can plot over one over another. Okay, like first I'm defining the data and what will be the mapping in x and y. In next I'm defining the geom line. What is the geometry of the line object that will connect the points? And third, I'm giving the different points. Okay, what we'll do, let's plot this. Now it has added the points over the line. It is layer by layer configuration. Okay, yeah, you can add more thing over that layer. If I add the point first and then add point at the line, then what will happen? It will go behind that line and line will be imposed over the points. Okay, let's see. Now you can see that this point is behind the line. That's why the line is visible over the point. Okay, so it is layer by layer configuration. Whatever you impose, it will create a layer for that. In next case, I will show up to this. First, I will show. Let's comment it. So to create a plot, first you in parentheses, first give the parentheses, and inside that you start same configuration, ggplot, data copper, mapping. In X we are giving, in aesthetic we are giving x-axis year, y-axis export, and also we are giving a color to the product as the product column as a color. So what this product column contains? It contains copper and other, these two categories. So based on these two categories, it will automatically map create two lines and give two colors, different color identifier. Okay. So let's plot this. And next geom underscore line, that is size 1.5, and geom underscore point, that is 2. Not getting your voice still, Mohan. Mohan, my voice is not clear. Please write down, everyone, whether my voice is clear or not. Please write down in the chat box whether my voice is clear or should I rejoin. Everyone? Okay, clear. So I think your internet has some problem. You can reconnect. Okay, clear. So now if I plot this, what it will do, it will create a plot, but for two different configuration, one for copper, another for other, because we have provided the color as product. Okay, the product column as color. So automatically it created based on a copper separate line chart and a other separate line chart, automatically based on the value that is associated with copper or associated with others. Okay, so in one go you have created this. Let's say I want to change this, whatever it is printing, I would like to change this. 2006, then 2007 is missing, but I want at every year interval it should plot the axis values. Okay, so what we can do, that also offers, after that next layer we will change the scale. scale underscore x underscore continuous. We're adding with a plus sign, and inside that breaks that at what interval you want to give the x-axis scale. Okay, so np.a range from 2006 to 2015, that will exclude the 2015 plot up to 2014 because the last one is excluded at interval of 1. So what it will do, it will now create every value of the year 2006, 7 up to 2014. Next thing is, let's say I want a different theme. This theme is little bit odd type of theme, but it is a default theme for Ggplot2, but it also offers different themes. If you type, say, just theme and underscore, it will show different types of theme is there, like classic, dark, gray, light, matplotlib theme is there, Seaborn theme is there. But I would like to add the theme of classic. Okay, so what will it will do? It will create a classic theme. So it is so much easy actually to create a plot. And now once you have that, next add the labels. Know your voice breakable. Then you check your internet. I think everyone in getting my voice clear and loud. So if your internet has issue, then you need a good internet first of all. Otherwise, you rejoin the session, I think. Then X level. Again, we have added the X level, Y level in matplotlib or Seaborn library lecture. Then plus X level equal to year. So I would like to give it is in capital. So year, and again Y level function, then USD million. Okay. Enter. It will now year and USD million. Automatically label the X and Y axis values labels. Next is the scale color manual that I would like to color, give it a color of different color. Okay, so I have a hash color, and you can also do that with scale color underscore manual because I'm manually editing, and there are automated color also there for the library. You can also import that, and in a list either you can write blue or red, it will also accept. I'm giving a hash color. Okay, so it automatically red and this blue color right now. Okay, and after that, to change the different aspect of the plot, there is a function called theme. Inside that, you can change everything. Okay, for Plotline library, you can check this. I will comment it out. So in theme, I'm giving that legend position. This legend position is right side. I don't want the right side. I want it to be in the bottom. So inside theme function, legend position is bottom. Legend direction, it should be horizontal, not vertical. It is vertical. I want horizontal. Then say legend title alignment, it is center. So it should be center of the plot here. And I also like to add what happened. Let's comment it out and show you. So now you can see that it is at bottom, but it also overrided some values. It is we have to shift this legend to a little bit bottom side or the south side of the plot, so that it will not override or overlap the values on the axis. So what we can do, we can ask a theme function to first legend box spacing, then this two legend box spacing I'm adding so that this red one and blue one should be separated a little bit. Then legend entry spacing X. So this one, what will do, it will increase the spacing between legend and labels. Okay, so this label is higher product, and this our legend that will separate it out by 15 spacing. And then I'm also adding and I'm also removing the product this name. Actually, this legend title I don't want. If you don't want that, you can also provide this as element legend title equal to element underscore blank, but I need that, so I'm keeping that. And then I'm also providing the label product is small, so with plus labels equal to color equal to product. Okay, so this automatically create the legend title capital product using this label function that will change the label for the legend. And also we have provided the spacing. Now it is little bit below of that year, and earlier it was overlapped. So right now the plot is ready. You can directly save this plot. How to save this plot? So the thing is, we have saved this whole plot function or the code in P1. So it will saved in P1, and we have plotted the P1. Okay, so that's why the plot is showing here. So right now, if you want to save this, so p1.save, the p1 object has a save function. Inside that images folder, I have an images folder. You can, if you don't have, you create that folder. And inside the images folder, I'm saving that plotline_lineplot.png and DPI is 400. If you press Control Enter, it will add. Okay, so if you see my images folder right now have plotline line folder, line chart, and this is the chart. Okay, so you can increase the resolution, DPI values. You can able to increase. You can also specify the size. If you hover this over this save, it will show that it also supports like width, height, and whatever the units. Here it is inches. You can also give it as a centimeter, millimeter, whatever you want. It also supports different units. Okay, so I'm saving as the default inches. Next thing is the dodge plot. The dodge plot. Okay, dodge plot we already seen. Okay. So dodge plot we have already seen. Here we are going to make a dodge plot like this. So over different year based on copper and other, that was a line plot. Instead of line plot, I would like to add a bar plot like this for every copper and other side by side for each year. Okay. So the functionality is same. I hope what is bar plot you have seen last day you have attended the lecture. And here how we will do that. The rest of the part is same up to this. So I will comment it out just to show you. So again, this ggplot copper data, you can also specify the data here. If you are using the in argument name, or if you are using the position based, then you can also provide the position. So copper, and instead of mapping equal to this thing, you can directly type aesthetic. It will take the position based argument in a function. So ggplot2, first you are giving the data set, then aesthetic x equal to year, y equal to export, fill color is product. So earlier it was fill color, not a fill color because it was line. So that was color. And now we are using bar. So bar has a area. So you would like to fill with a particular color. That's why you're providing instead of color, the fill. So it is product. Okay, element blank. Explain legend title part. Okay, in last part. Actually, this legend blank, what it does, this legend has a particular name, product we have created. If you don't want, sometimes what happens that it automatically, like for bar plot, you automatically specify here the legend configuration, or sometimes people what they do actually, it automatically writes at the end that what this line means or what this bar means. So sometimes we don't need this such a legend title, what that actually means, because if you are writing, it is a in a journal that it is a plot for the products, or over the year, what is the export for the products. Then you don't have to give, say, sometimes people give this product title for legend, sometimes they don't. So if you don't want this, because here it is showing, but if you don't want this, then you have to give this legend title equal to element underscore blank. So I don't want this element to be plotted in my plot. So that means that element underscore blank, keep it blank. And if you run that, it will remove. That is the purpose. Okay. My internet is highly interrupted, so I am unable to gain anything. So I think then you will get the lecture session, recorded session. You can watch that. There's no issue. It will be available by the end of the day. Okay. So in the dodge plot, again, this ggplot2 copper, aesthetic, x year, y export, and fill. This time we are giving instead of color fill because it is a bar, it has area, and column gem underscore column is equal to position. Gem underscore column, why we are giving? Because it is a column like structure. The ggplot2 supports two things. One is gem underscore column and gem underscore bar. Okay. So if you provide gem underscore column, it will take the raw values of the data set. Like this export has raw values. But sometimes, say if I want to plot this, sometimes you want to plot for a tips data, say number of day count in a data set, like how many days are Tuesday, how many days are Sunday. That count you want to plot in bar. That case you have to give instead of bar. Okay. Instead of column, you have to give bar. What this bar does, it automatically in the background has to count the number of frequency of the y values, or that if you are providing day or categorical column, automatically it count the frequency, how many days are Sunday, how many days are Saturday. So if you provide the gem underscore bar, that has a count function. So instead of counting, because we have already a raw data that we want to plot here, like export, and we don't want to count. So that's why I'm using here the column function. Okay. So column function automatically picks the raw data from the data set. So geo_column, and how we want to plot that as a dodge form. So position equal to dodge, that you have to give. And it automatically, my mobile internet is also not working. So if I plot this, I'm saving this in P21, and right now I will plot this and see how it goes. Syntax error, why? Because I've given additional parentheses, I guess. So now it is a plot. Okay, this looks like bar plot, and right now the years are also a little bit odd. We will change that. So next thing is, instead of right now, I will not talk about this text. It is a little bit advanced. I will show it later. If I possible, I will post it. Okay. So right now the scale, again, it is same thing, 2016 to 15 at interval of 1, excluding the 15. So if I print that, it automatically add the labels for the x-axis. Then this, I can also give a title. So GG title. Okay. So function is there, and inside that composition of exports over here. Then again, X level, Y level. Okay. And if you would like to use a different kind of palette, so scale. So earlier we have given a scale color manual with 2 color. Okay. And this Ggplot or Plotline also supports some color palettes. Okay. So it automatically create the color combination for you. Like different types of color palettes are there, like sequential, diverging, like from middle, left side and right side. From middle portion, the color will be different, and there's a qualitative also there. You can search this in internet, and you will get what is a sequential color palette, what is a diverging, what is a qualitative. So here I'm using the scale fill brewer, type is qual. Okay. So and palette is ascent. So qualitative, that means qual, and palette name is ascent. Okay. So if I plot this, now the color palette is like this. So green and little bit violet color. So next thing is again adding the theme, classic, and also next the theme portion is same, because we want this to be at bottom with a spacing, this legend. And if you P21 haven't, okay, here, okay, we haven't added another, because theme has a curly braces, it will end here, and for whole plot it start here, end here. Okay, so now it will run. So now we have the plot. You can export it directly. You can use it as a plot for your journal, and you can also import or save it using the figure object where you have saved, then .save. And again, I'm saving this in images with dodge bar plot DPI 400. So if you run that, it will save. Okay, now you can see dodged. This is the plot. Okay. Similarly, say I would like to plot a day-wise count for tips. Okay, which one? Stack bar plot, I guess it is a stack one. It is for tab. Okay, tips dataset. Okay, so instead of that copper dataset, we can also do it for the tips dataset. That time we have used the column geo_column. Okay, because we have the raw data that we want to plot. Right now, I will show you that how to use geo_bar. That also includes a statistical computation part. It automatically compute the counts. Okay, and where we have to provide the categorical variable. So these things I will. Okay, these things I will. These things are not required. That is in commented. Okay, because it is a count plot. So I will start with, again, this is the tips data. We are already familiar with that. Your voice is. This is the count data, tips data, and you are already familiar with that. And here to plot that bar plot with count of say day. So what we'll do, again, Ggplot, the dataset tips. In aesthetic x-axis, I'm giving day, and fill will be based on sex. Okay, so male and female. And now instead of geo_column, I'm using geo_bar. What we will do, we are not giving any y value. what it will do, it will automatically compute the different number of counts of the days in the data set, like how many are Sunday, how many are Saturday, how many are Friday, and it will plot as a bar. And it also divide, we are providing this fill equal to 6. That means it will also divide. Please provide me all video lecture. It is already available in the file tabs up to day 5. The videos are already available in the file tab in MS Team. You can go there and download it. So Ggplot, under that tips data set in aesthetic x-axis, we are providing the day, and we are not providing and we are not providing the y-axis, what it will plot in y-axis, because it automatically count the number of different count of the days, like how many Sunday, how many Saturday, and plot in the y-axis. And we are giving the fill color as 6, so it automatically divide each bar into 2 for male and female. So here, instead of gem_column, we are providing gem_bar, then position equal to dodge, and color equal to black. So the edge color will be black. Then we are providing the GG title, the title of the plot, X level, Y level, then again the color palette and theme, and the theme customization, so that it will plot the legend at the bottom and with a spacing. So if I plot this, now you can see it is providing the count. Okay, so for Friday and for Saturday, you can observe that it is the legend is for female and male, and it is still overlapping. So you can also increase the padding here. So let's say 18 or more, say 22. Okay, box spacing, it is not this one. 15. Box spacing is 6. It will do or not. Okay, so now it's spaced actually, and the legend entry spacing X direction, let's make it 20, so that it also not overlap. Okay, now female and male is properly visible. And here is the count. So you can see that for male, most of the samples are for male in Saturday and Sunday, and the females are more present. Number of female samples are more present in Thursday. Okay, so this is the main functionality of between bar and column. Column plots the raw data, bar is for counting purposes or some statistics. Next thing, I will go for a stacked one. How to do that, but instead of side by side, one over another. And here we use the copper data, same again the data. We already know that Ggplot contains this copper data, aesthetic year, x-axis, and y-axis export, and fill color is product. Now in geo_column, instead of dodge, we are providing position equal to position_stack. Okay, and if I don't provide this reverse equal to true, what will happen? Let me show you. And rest of the thing is same. Okay, so now it is providing the others at bottom and copper at top, but I want it to be reversed. I want this copper other to be in top and this copper to be at bottom. So here that's why I'm providing reverse equal to true. Now the other will be at top and the copper is at bottom. Okay, that is the purpose, and rest of the things are same from here to here. Okay, loading bad network quality. If anyone facing network issue, then I will request to you join with a good network or wait for the session to end. At the end of the day, we will provide up the lecture will be available as video file. You can download it. Okay. So you can save this same way. Next part is a scatter plot. That is a plot for comparison of two numerical data like this. Okay. This is a faceted one, but for single, I will show how to plot it in aggregate manner and then how to create this one. Okay, this is the relation to show the relationship between two variables using points. Okay, we have already discussed last day. So I will again read the tips data set. Then I will describe it to see with a transpose. And you can see the different counts, mean, standard deviation. And now I will like to plot the relationship between total bill and tip. So total bill should be in x-axis and tip in the y-axis. I would like to see whether my tip is increases with increase in the total bill. Okay, so same way the Ggplot, again tips data set name in aesthetic x-axis I'm giving total bill, y-axis tip. So it will plot x-axis total bill and y-axis tip, and not giving any filling. Then gm underscore point, because I would like to denote every xy value position with a point marker. Okay, and the size of the point would be 3, shape will be circle, and color will be blue. And gg title of the plot, x label, y label, and theme is classic. If I print that, it will show me the plot that as the total bill increases, our tip given by the customer is also increases. Okay, also increases. So next thing, to customize it. Okay, before customizing it, I will not show this first, this faceted one. So again, the tips, aesthetic, total bill, tip, white tip. Now we are also coloring these points based on two things. One is for male, another for female. So I'm giving a fill color of sex. Okay, so sex column. So it automatically, someone has. So that will plot the x and y value and also provide a color and for the male points and for female points. Okay, which samples are for male and which sample are for female. So gm underscore point, again same thing, size 3, shape is 0, then scale, because the range is 0 to 51, I'm breaking the I'm providing the scale with a continuous x dot continuous and breaking it to 0 to 51 at an interval of 5. Rather than showing 10, 20, 30, I would like to plot it 0, 5, 10 at an interval of 5. Okay. So next thing, again gg title of the plot, x label, y label, then giving a particular color scheme, and type is here is the quality, palette is set 1 I'm using, and name is diamond cut. Okay, I'm giving a name also, that name of that palette. So theme classic again I'm using, and theme position same because legend should be like this. And if I plot this, it will show me this, that the red one is for female and this light blue one are for male, and now it is like this. So next thing is a little bit advanced. I have already showed how to make separate plots such based on a particular column, that is a categorical column. Let's say I would like to say create, instead of creating separate plot for day, I would like to create a plot that is for, say, I will take it out outside. So I would like to plot different plots for say day, but it's say for row wise. So how we have to give? So first, this tilde sign means that it will separate out the row and column. Before that, I have to provide, if I provide the column name, that will, based on the column name categories, it will provide it in row wise. And after tilde, if I provide, then it will provide the column wise. Let's say, for example, I would like to plot the separate out this plot based on all the days, 4 days. And that should plot the row wise. And here I have to give a dot. That means no column. I don't need column wise, but I need only for day wise. So before tilde day and after tilde dot, I don't want column wise. And if I now print this, it will compute and it will plot. So day wise distribution, day wise plot for tip and total bill, and the colors are based on female and male. And it is not column wise, it is row wise, row 1, row 2, row 3, row 4. Let's say I would like to add the time also. But let's say I would like to plot it column wise. So here I will add day, and here in row position I will add dot. I don't need row wise, I need it column wise. So now it is plotting column wise. Okay, so little bit is these values are congested. You can also change that. It is also possible. And next thing, instead of giving just a one based on, I would like to plot all, separate out the plots row wise day, but column wise for say time. Okay. So it will generate the plot. So row wise is for day. You can see that Friday, Saturday, Sunday, and Thursday. And column wise is for time, dinner and lunch. This two plot has no data. That's why it is blank. So this plot indicates it is for dinner data, and where the data is for Friday. Okay, this plot. Similarly, if you see this plot, that last one, it is for Thursday and it is for lunch. Okay, and this is also categorized into male and female. That way you can also investigate any kind of relationship, whether the data is available or not, whether trend is linear or not, day wise, you can also check that. And that is the beauty for this Plotline package. It is very easy to do. With this small, with facet underscore grid, that we are want to facet it or create separate plots based on row and column. Okay, so row wise, day wise, take the day values or unique values from the day and put it row wise, and take the unique value of the time, that is dinner and lunch, and put it in column wise and separate out the data and plot it. That means only that. Okay. So next thing, we can also save that. Next part is a histogram. So in Ggplot, to histogram is also very easy to plot. Same like, let's say we want to plot the distribution of the total bill. So in Ggplot, again, first you have to give the tips, dataset name. In aesthetic, just you have to provide the x-axis value, total bill, because it automatically count the bins. Okay, so what would be the plot? This is a faceted one, but I will first show the aggregate one. It will divide the range of this total bill into small bins. Okay, the network is fine for. So please check your internet connection. Should I rejoin again? My voice is clear or not? Please, everyone, write in the comment box. Or should I rejoin? Clear, your voice is clear. And screen is visible. I am talking about this. Okay. Then I will proceed. So it is a faceted one. I will show a combined one. What is a histogram does? It creates small bins. Let's say the range of this total bill around 0 to 3 to 51. I would like to divide it into 50 parts, or say 10 parts. And whatever the value in our data set falls in a particular bin, that I will count. Say for 0 to 5, I have 5 observed, 5 count, 5 values in our data set. The total bill are falling in that bin. Similarly, for 5 to 10, what are the values falling in that bin? In 5 to say 15, 15 to 20, 20 to 25, up to say 55 or 50, whatever the max limit. And that count I am plotting here. That is just a distribution or histogram. Okay. So first we will show that how to create an entire histogram for entire data, and then I will facet it. Okay. So again, Ggplot tips and aesthetic, just you have to provide the column name, that is a x-axis total bill. Then geom underscore histogram, the geometry that which we want to represent that plot is a histogram. So geometric underscore histogram or geom underscore histogram. Then y-axis, what we want to plot. In histogram, you have to define it as a statistics. Whenever there is a statistical thing, you have to use a dot both side. Okay, that is a notation. So in a inverted comma, in y-axis dot count dot. That means I want in y-axis the counts. And I would like to fill the histogram bars with white color. So fill color, and color equal to black. That is a edge color for the bar, and bin width is 1. So divide the entire range to 1, 1, 1, 1 with bin. You can also change. Here we are not providing the total bin in which we want to divide. I want that bin size, bin width would be 1. So it will, if it is 0 to 50, then it will create 50 bins and check which values are falling in that bin and count it and plot it in the y-axis. Again, GG title, X label, Y label, and theme. So if I plot that, it will show me the distribution of the total bill. At every bin is a $1 actually, because it is in dollar and it is around 3 to 51. So 1111. If you change the bin, say I would change the bin to 4 or say 3 bin width, then the bin width is for 3333. Okay, and it will count how many are falling inside that bin. Similarly, I'm also changing here the plotline figure size because it will take some space. And here I will show using the faceted how it look like when we'll separate out the plots based on a particular categorical variable or column. So this thing Ggplot is same in x-axis total bill, geom underscore histogram is count, and mapping here. In mapping, I am also in histogram also you can also add this mapping or aesthetic attributes. Okay, so to change the histogram aspects, so inside that I'm also again giving the mapping aesthetic fill with day. So based on the day it will fill, and the color will be black. The border bin width is 1, and here I'm faceting it with row side. Okay, row wise, so day wise in row, and column wise is dot. That means I don't need column wise. So day wise distribution will be row wise, it will plot the day wise distribution. Okay, and rest of the things is title, label, theme, and the position. And here one thing is there that I would like the label of the legend to be in this order: Friday, Saturday, Sunday, and Thursday. So scale, fill, discrete, name of the legend will be day, and labels should be in this order as a list. So if I plot that, it will create the plot, and the plot is available in a faceted form in row wise. The day are in row wise, and every row contains the data for that day and what is the distribution of that. Okay, so you can save this. And next we will do it for a smooth version of the plot that is also known as density plot, the smooth version of the histogram. If I create a smooth version or estimate the kernel density, that is a smooth density function that will impose over that distribution, and we will compute in next we will do that. So similar to histogram, the ggplot part is same. Total bill, and I'm also giving a fill color of day. Okay, so that it will fill based on the day, and so it will overlap one over another. Okay, and then geom underscore density and alpha equal to 0.4. This is the opacity, means what would be the whether I would like to. Okay, okay. Well, so alpha value means it's the opacity. Opacity means whether you want the full color or it should be dimmed little bit, so that if one plot is overlapped with, over another, like one density plot for say Sunday is overlapped over say Saturday, then it is clearly visible that behind that Sunday plot is also available. Okay, so same thing for GG title, label, and themes. And if I enter, it will create a day wise the smooth version of the histogram, and it also gives a color scheme, and we have given opacity of 0.4. That's why it is the background, the back one distributions are also visible like lines, that how it's going. Same thing if I for here we have done for total bill, and okay, here we have faceted actually. So this is nothing but here I have added just a facet column to see to break it for say day wise, and scale is free. That means it will plot as much as such a space is required for that. Okay, and theme, in the theme legend position is none. I don't want legend. I want to remove the legend. So to remove that, theme legend position equal to none. So now you can see, because it doesn't require legend already, it has identifier Friday, Saturday, Sunday, and Tuesday. Why I would need a legend for that? And now I have faceted it based on the row wise day for using the day column, and column wise dot. That means not column wise. It is like this. If you want to add as a column wise, say I want to the sex as column wise. So please, if I add enter, it will also for female and male, it will separate out and create the plot. Okay. So next thing is a box plot. So I will save that image, and next thing is a box plot. We have already seen the box plot. This is a box plot, that the middle one, not this dotted one. These are the B sum plots. I have overimposed to see how the distributions of male and females are over that box plot. Okay. So first we will just create the box plot. That is gives a 5-number summary, like what is the first minimum value, first quartile, median, then it's a third quartile, and maximum and outliers. Okay. Similar to here we will plot the total bill, and it shows the relationship between a categorical variable like say here day and a numerical variable, the distribution for which day wise we want to plot. So total bill. So again, ggplot data equal to tips in mapping inside aesthetic. The x-axis you can directly give here x. I am not giving. I'm giving positional argument. It is also take like this. The first one is for x and second one for y. So x day and y total bill. Then what I'm doing, that geom underscore box plot with equal to 0.3 of that as a box plot. So it will add the box plot, and the next level y level and title. If I plot this, it will show me like this, the box plot for Friday, Saturday, Sunday, and Thursday day wise. And this is the median value, that is line. The first is minimum. This line is for first quantile Q1. It is for Q2, that is median. It is Q3 75 percentile, that is for maximum, and these are above 1.5 IQR of this Q3, and that's why they are outliers. And if I would like to add the say some points here to show how this the distributions is look like, because it is a box, I'm not able to see how the dots are distributed over the total bill. I can add a geom underscore jitter. What it will do, it will add some points with some jitterness, that means with some randomness, okay, so that it will not overlap in a line. Like if I don't add this, it will add dot 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 like line, but you will not able to observe the number of observations are there. So next, let me comment it out. Gem underscore jitter, and aesthetic is fill equal to based on sex. So based on sex, I would like to fill it. This jitter points, then size equal to 3, and position, how the position will be. So position, because if I want to add 2 based on sex, then I have to also define that it should be in Dodge form, like here and here. Okay, 2. Because otherwise it will plot for one over another, like for male and female. But I want the male to be left, dot dot dot, all the dots to be in the left side, and for female in the right side. Okay. So how it? So we have to provide the position equal to position underscore jitter dodge, because I would like to jitter the points in dodge form. Then jitter width, how would be the width, how much it will distribute in the horizontal direction, and dodge width, what would be the dodge width in which the 2 dots are located. And shape will be circle. Now you can see that over that box plot, a jitter, this dotted with some randomness in the horizontal direction has been plotted. One is for female, that red one, and that is for male. So it shows that with median, how the points are distributed across the total will. Okay. So for this, you can see that very small observations are there. For this, it is very large number of observations for male, but very small but dense here between 15 to $30. Okay, that is generally to identify how the values are distributed over the vertical range. Okay, and same way here, a little bit I have added customization. Same thing it is, but I have added some little bit customization. Like I have added a fill value so that it will show the values to be colored, and everything almost same. And right now it is same plot, but I have added some customization color. Okay. Next thing is linear regression plot. I hope most of you know what is a linear regression. Linear regression is a modeling technique where we like to predict the continuous data. Like I would like to predict the tip value based on the available data I have, like what is the total bill, what is the sex, what is the day, what is the time. And to do that, we usually use a linear regression because we are trying to predict the continuous data here, like if I show you, like here, the tip is predicted by, say, I would like to predict it based on the total bill column, and say plus day plus say time plus say sex, this 4 column. Based on that, I would like to predict the tip. If I just use this, okay, this tip versus total bill, it will show me we can add a scatter plot, and inside the scatter plot we can add a line. I have already shown that. Let me again show this. Open the file. Okay, from here I will also able to show this. Okay, so no problem. So again, the Ggplot also offers to add this linear functions or linear this line. And also you can, if you are using predicting a binary data, like binary logistic regression or multinomial logistic regression, you can also able to add this S curve that is used for the probability estimations. I will not go into detail because many of you might not be familiar with that. So I will just show how this linear regression line will look like if I if I would like to predict the tip based on total bill. So X is total bill and Y is tip here. So Ggplot, again, the data set in aesthetic total bill X and tip is Y. We can also add color later, but I will show later. So gm underscore point. So because it is a point plot or say scatter plot, so it should be using represented using the geometry of points. Shape equal to circle, size is 3. Then gm underscore smooth. What happens if I don't provide that? Okay. So what happened if I don't provide that? If I add a gm underscore smooth, it will add a Lewis line or smooth moving average line. Okay. And X level and Y level, if I add that, you can see it is providing a smooth lowest type of smoothing moving average calculated line actually. Okay. So but I want it to be linear regression line. So what we have to provide here, method equal to LM, that is linear model, and inside that standard, so the error bar or the confidence interval to be false, SC equal to false. False. Okay. Now you can see it's fitted a linear regression line. Okay, that line will able to give us what would be, if I give a total bill value, say 20, what would be the predicted value of the tip? Around say 3. What would be the 40, corresponding 40, it is around 5. So like that, this line will be created or estimated based on the a concept that is used in for optimization or finding this best fit line, known as such an ordinary least square, OLS. Okay, so it minimizes the distance because the what will be the best guess if I have this don't have this line? The best guess would be the average of the tip. So if I ask some person that what is the if I give you what if the bill is 30, what would be the tip? You can say that averagely it is around 3 because the whole data set has 3. But it is not the best guess because if I go for 40, it could be 5. If I go for 50, it could be 7.5. So that way we need a for linear regression, we need a particular line that best fits the data using a least square or ordinary least square regression method. And this data, whatever the fitted line we are getting, that has also associated error, but it will minimize the error. Now, if I ask someone that what you have got a 20 rupees bill, what would be the tip? Now you can say it is around 2.8. And if the bill is 50, then it is around say 6. So that is the advantage. And this changing this, you can also plot and see how the regression line will look like. I will show the estimation process in the evening lecture where the linear regression is there. Right now time is 11:27. Okay. So next thing, how to facet it. Okay. So again, Ggplot tips and aesthetic, x-axis total bill, y-axis tip, G_point. It is a circle marker, size is 3, and mapping color. I'm also giving the this point geometry to be colored based on day. Okay, so mapping aesthetic color equal to day. So I want this geometry to be or points to be represented in 3 colors based on the days. Then G_smooth method equal to linear, standard error equal to false, and color equal to blue. This line would be in blue. Then X level, Y level, and I'm faceting it based on the sex in the row wise and day column based on the day column unique categories in the column wise. So row wise sex, column wise day, and rest of the things are same. So if I enter, it will give a plot. So row wise sex, so female, male, and column wise Friday, Saturday, Sunday, and Thursday, and this is the plot. And it shows that how the day wise slope is different for different regression line. Like for Friday, the slope sample is very low, but if I go for Saturday, the slope is almost like this. But for Sunday, the slope is little bit for female, it is higher. So that means they on an average usually pay more. And similarly for Saturday, for male, it is slope is high, but for Sunday, for male, it is a little bit flattened. So in Saturday, male are on an average provide higher tip. That could be the interpretation, but you can go more in detail of that. And for say Thursday, male and female slope are almost same. Okay. So next I will show the Ggplot that is not under Ggplot 2. For that I need to use the SciPy library. That is usually used when we have to confirm that whether a particular column is normally distributed or not, or some follows the sum distribution like beta distribution, log normal distribution. And you would like to if you read you have read paper, then many people use some statistical hypothesis test to confirm that, or use a Ggplot, quantile plot. Okay. So what it does, it first compute whatever the column you will give, it will compute the quantiles, and that is our empirical quantile values. And also the normal distribution has a function, defined function, where we can provide the it is a well-established function, okay, and where we will provide the mu, that is our mean, and standard deviation SD, and it will generate the random samples, and that is known as theoretical value. Okay, so you theoretical empirical theoretical equation you can use that well-established equation, and you can generate based on our current data standard deviation and mean, and you will also generate the quantile values for that, and compare that whether the theoretical quantiles and our current data set, the empirical quantiles are exactly matching or not. So how this plot look like, I will show. I think this. So it's look like this. So if the theoretical quantile and sample quantiles, that is from our numerical data set, both are similar or almost same, then it will fall in this diagonal line. Because if it is matches, then it is diagonal line. If it falls in this diagonal line, that means it follows that distribution. 100% it won't fall, but some part. Like it is not falling, it is not normally distributed. But maybe it is following some other distribution. So further due to other distribution. So how to create that? So let's say again I am using here the matplotlib method. We have to load the two module. One is called the stats model module. So you have to install that also. The pip install stats model or conda install as a stats model, it will install. So import stats model from statsmodel.api. We are importing this as SM, that is our nickname. Then from scipy, we need the stats. So scipy.stats, we are importing it as a stats. That is our scipy's nickname for the stats module. And matplotlib.pyplot as PLT. We have already seen that. So I'm creating a figure and axis object, plt.subplots. The figure size will be 12,6 inches. And then I'm calling the SM. So sm.qqplot. SM has a functionality known as qqplot. Inside that, I would like to know the distribution of the, say, total bill. So tips, from that I'm selecting the column total bill. You can also use the log operator dot log colon comma this column. Okay. Then I'm giving also plot a line 45 degree, fit the statistics and try to see. Then distribution should be here. From stats module we are taking the norm. So we would like to compare with the normal distribution. So generate the theoretical quantile values from normal distribution and compare our empirical data such as quantile values and see whether they are falling in the line. And axis equal to axis. And I'm saving also in the images folder plot9, not plot9. It should be qqplot. Okay, so it will generate the plot. Let's say I'm not convinced with that. I would like to change the distribution. I would like to see it is not normally distributed. It is not falling in this line, red line. So whether it is a beta distribution, I can change the distribution here. It will compare with the beta distribution then. Yes, it follows a beta distribution. Almost all the values are in this line. Whether it is a log normal distribution, log norm. Yes, it could be a log normal distribution also. Okay, so that way the scipy modules of the statistics, if you go to the internet, scipy, so let's say I want to know whether it contains the beta distribution. Yes, it contains. So stats.beta. So it also contains the beta distribution. Similarly, log normal, scipy, log norm. All type, it is around 110 type of distribution it supports. You can compare any kind of distribution. For that, I have also created a application. I will load that. Okay, so I will show that. Okay, so this way you can also check the whether a particular column or say data values follows a particular distribution or not. Okay. So next thing I will introduce little bit of Plotly, that is JavaScript based. That is very wonderful and beautiful because it will be interactive. And you can also create dashboards. Like if you change the X value, X column name and Y column name, it automatically dynamically change the plot. Okay, that is in that application is there. I will show you. So first you have to install the Plotly library using the same method, either conda or pip. So import plotly.express.px. Express is the module that is for quick plot. Okay. So we are taking the tips data set from the Plotly module only. You can also read that. So px we have imported as alias px. So px.data.tips. It automatically load from the Plotly server this data set tips. Okay. So it is tips. Next, I would like to add the histogram, but it would be very interactive. Just watch. Okay, so px, that the alias, then histogram, then the data set name is tips. In x-axis, I'm giving total bill. Color should be, because it is a histogram, just we have to give x. I'm not giving y. So it will automatically count the frequencies. So color, based on color, I would like to separate out or overlap one over another, male and female, based on the sex column. number of bins, divide the number of bins to be 30 and it will count what value falls in which bin. Then margin rug means the rug lines where the density is more or where the density is less. I will show. Okay, and then hover data. I will remove right now hover data and show you just the plot. Okay, so if you create this plot, it will little bit take time because it's loading Plotly, I guess, for the first time. Yes. Now it is a interactive plot, and we have already asked that it should be colored based on male and female. So male are in red, female are in blue. So now if I hover it, it will show that this bar, this blue one for sex female, total bill ranges 16 to 17.99 and count is 14. What about the male one? So male here 16.7, the range is 16 to 17.99. That is around 2, the bin width, and count is 18. What about these rug bars? This rug bar shows where the more dense observations are there. It also shows like this. Now, if we would like to make a facet, it is also possible. So facet row, divide this plot based on the time row wise. So it will compute. And now you can see the time is for dinner, time is for lunch, and you can also see, you can hover. Okay. And if you would like to just plot, say for female, okay, just of the male, it will show the female. It is interactive. Or say I would like to plot the both, or I would like to investigate this part. It is there. You can do that. And again, if you want to go to the reset this plot, just go to home. You can also plot this into web and share with anyone. That is also Plotly server provides. Okay. So this is the functionality. Let's say instead of this, I would like to plot a cumulative graph where the number of bins will be added and it will go up to 100. So you can also do that. Cumulative equal to true, and it will plot a cumulative distribution plot. Okay. So here the 150 is the maximum range of the count, so it will reach there. Okay, and for lunch also. And say in hour, it is showing just meal, dinner, then total bill and count. I would also like to show the columns, all the columns. Okay, so hover data equal to tips.columns. So the column values. So now it will show or not, I don't know. It will not work here. Okay, that way you can also change. And next thing I will show the box plot. So px.box, then tips dataset. In x-axis I'm giving day, in y-axis I'm giving total bill. Color, based on color, the box should be dodge plot. Parallelly it will show for male and female. The points also all, that means it also add the jitter points that I have shown in the Plotline. Okay, and hover data inside a square bracket. When hover data means, hovering means when I hold the mouse pointer over that, what it will show, like here, what is showing, what you would like to show. I would like to show that the tips.index, what is the index value of the tips data set, that wherever I will click or hold the pointer, here will automatically it will show the point will belong to which index value of the data set, which index, whether it's 0, 1, 2. Let's say it is an outlier I want to identify and remove it later. So how will do that? I need the index value. So here I'm also giving that show me, while I hover, show me the index values. Also show the smoker column and the size. Okay, so let me show that. Now it is a box plot. And if I hover over a particular point, let's say I found that it is an outlier. I hover that point, it's showing that it is a male, day Saturday observation, total bill is 50.81, index is 170. So if I have to remove, then I have to just drop the index 170 from the data set. We know the drop method. Okay, based on the index. The smoker is yes for this observation, and it is a size of 3 observation. Now if I hover over the box, what it will show? A little bit I hovered. It will show the from top is the max, then it is the upper fence, then it's showing that is Q3, 75 percentile value is 24.21, then median 18.24, then Saturday Q1, that is a 25 percentile, and then minimum value that I have already shown. It is dynamic. Okay, So same here for if I hold that for female one for Saturday, it will show like this. Okay. So that is the end for this lecture. Just I will show another thing that I have created a distribution fitter, because to identify which distribution actually fits your data set, sometimes we need to actually report in our journal so that we can somebody can generate random samples from that. Okay, like in my pedestrian research, I usually plot the pedestrian speed or say waiting time at the intersections, or waiting time to cross a particular through a particular crosswalk. What would be the waiting time in a signalized intersection? And that kind of data, I have to plot this kind of histogram, and I have to get a density, what type of distribution this follows. Like here it is normally distributed, if you know the concept of normal distribution or bell curve. Okay, and what type of this distribution the data currently follows a distribution, to identify that it is very much difficult, because there are 130 distributions are there. Every distribution comparison is not possible. SciPy library supports around 110 distributions. So there is a library called distfit. You can go through this block. I will share. That is a library called fitter library. Okay. So this fitter library uses in backend the SciPy only. So from SciPy, it will take all the distributions and compare with your data and give a ranking based on AIC, BIC value, and also the sum of square error. Okay. So I will show, based on that, I am created a Streamlit application. Streamlit is a framework that could be used for making interactive application with very few line of code. So I was looking for distribution fitter. There is a easy fit software is there, but it is costly. And if you install it, it will expire in 30 days. So I got frustrated. And then I look for what would be the best solution. Then I look for the distribution. SciPy supports around most of the distributions. Okay. So that case, what I did actually, I thought first writing this blog. So I written this blog, and after that, I realized that everybody should use that. So I have also created application based on the Streamlit and also put it in the Heroku server. Okay, so from that link, anyone can access this, and you can upload your data and fit the distribution. How it works? This is the home content. It contains 3-part: home, exploratory, data analysis. That gives the exploratory part, like what is the descriptive statistic, histogram using Plotly, and distribution fitting. There are two ways you can fit. One is it will fit the top 10 common distributions, and another is it will from a drop down menu you can select multiple distribution and compare. So let's go for exploratory data analysis. If you go that, it will ask you to drop a CSV file. Let's import our say desktop, day 6 data sets. Let's say I will want to use this concrete data set. It is a or say tips data set. Let's go for the tips data set, because it is we are familiar with actually. So automatically it will we have selected the descriptive stats. It automatically shows the description of the data set, then data types, and also descriptive summary, like what is the count, mean, standard deviation, 25%, like this. Next, I would like to plot whichever the column I would like to plot. I would like to add the plot the distribution. Before have to add at least almost some idea about what kind of distribution it could be. So that's why I added this visualization part. And if you go, it will run, it will take some time. And now we have that histogram. It is plotting for total bill. Okay, directly taken by default total bill. Let's say I want to plot for say tip, and the number of bins I would like to add, say 50. Automatically dynamically plot, and you can also expand it based on if you would like to select and see the distribution. It is also possible. Okay, so that way it is sort of almost showing that it could be, if I give a distribution, if I change the bin size, distribution changes actually. Okay, so you have to careful the number of distribution. It automatically shows that it almost follows the log normal distribution or beta distribution. So next part is fitting part. So again, go to this menu, distribution fitting. Whatever the last one is selected, it automatically selected the tips data set, and it automatically by default selects the fit common distribution. Okay, it will fit top common distribution 10. Top is there. I have given a limit so that it won't fit every distribution. Otherwise, it will consume my resources, because many people use that. So next, the numeric column. Numeric column you have to select. Okay, categorical column it will not work, because it is for probability density function, probability, not probability mass function, probability density function. Okay, for continuous data. So let's say I would like to plot the total bill and number of bins. Let's say I would like to give, say, 30 bins. And what would be the error criteria? Based on it will automatically optimize it and rank the which is the best distribution. Say instead of AIC or BIC, AIC is archaic information criteria or Bayesian information criteria. Let's go for the sum square error. And here maximum you can go 10. So I will like to show top 5 number of distribution to show. If you click this process, it will automatically give some animations, and at the end it will give all the comparison of the top 5 distribution. So here the top 5 distribution. So it shows the top distribution that has minimum error. For the sum square error is minimum for log normal distribution. Then chi-square distribution, gamma, Rayleigh, and Cauchy. And it also gives the plot how it fits the distribution. Like for log normal, this orange one, it fits almost good. Now, if you would like to add, download the CSV file, you can also click and it will save the CSV file. And if you open, it will show the different parameters. Say you want to know what would be the different parameters to reproduce it, this value, the log normal, the AIC, BIC, and it will also give you the parameters at the bottom. Let me close it. So for this distribution, that is our top distribution is log normal, it automatically says here the log normal distribution fitted parameters are. So S is the shape parameter, location parameter, scale parameter. It automatically provided you all the parameters. Now you can use this parameter, go to SciPy, use SciPy library and reproduce based on, this is based on your data, and you can report that if you use these things, you can reproduce my distribution. And also, it also automatically generates what would be the link if you want to read more. So it is a log normal distribution or best distribution. Automatically, it creates a link, SciPy log normal distribution documentation link. If you click that, it will go to the SciPy page and automatically open up the log normal distribution. And you can read what this shape mean, location mean, what is the equation, everything is there. The next thing is if I would like to, instead of this top 10, I would like to I would like to manually select what distribution I would like to compare. Okay, so here is the option, select fit selected distribution. Okay, now it will give another bar. Here I have to click, it will show me what are the distribution available. So let's say I would like to compare beta. I would like to compare, say, exponential normal distribution. Say I would like to add chi. I would like to say gamma. I would like to say normal, log normal, log normal, log norm. Then I would like to say normal distribution n. Hover like this. Now, this 6 distribution I would like to compare, and for total bill, bin is same. And instead of sum square error, I would like AIC, and I would like to report the top 4. So process, it will fit all the distributions, and it will return all the things I want and give me the top distribution. Okay, so it shows that gamma is the best distribution for this data based on the comparison. If I use the AIC as our metric, so, and this is the distribution, you can download the file, and corresponding the gamma, it will also show the parameter A log scale. If you want to read it, just click, it will automatically generate the link for the gamma distribution. You can read that. And this blog is already available in my Medium, and also you can access my website 10.blog. Here it is also available. You can go for the link, and you can, if you would like to read, it is also available there. Okay. So we will take a break for 10 minutes. We will rejoin 12 with the SciPy library statistical comparisons. Okay, that module I will show that how to do different types of tests, statistical tests. I will not I will not go into detail how this computed inside. That you have to go over the days if you haven't taken any statistical class. But assuming that you know, I will show just to demonstrate. You can use that code to generate those things also. Okay, we will join after 10 minutes. I will write down here 12, I guess 12 o'clock. Okay. So this is the Plotline hand session, and we will join with the hypothesis testing. So I hope this gives some benefits to you, because I have also created this hypothesis test so that everyone can use Python for doing that. There is no need for other software. Many people use MATLAB. It also supports, but it is not free. I don't like it. So I usually prefer open source packages. Like R is for statistical analysis, R is best, but Python is also catching up. So Python has also almost every type of statistical analysis. Even you can do simulation for statistical analysis. We will join at 12 o'clock. Okay. So I will mute right now. If you have any question, you can put in the comment box. So it is a 12:01. So I will resume the session. Okay, am I audible and my screen is visible? Please comment in the chat box. Whether I'm audible and my screen is visible, please write in the chat box someone. Then I will resume the session. Okay, audible and visible. Okay. So now I will resume the session for statistical tests or mainly hypothesis testing. So for our research work, we usually have data, but we would like to check some hypotheses, like whether the two data sets are similar or dissimilar, or you have, say, for randomized trials in bio or bioscience departments, people usually divide into several groups, and one group given a particular medicine, another group given a placebo, and they would like to compare the data or see whether there is an improvement. Or for example, you have a single land where you would like to test two types of fertilizer and want to see which fertilizer increase the yields. That could be also tested using hypothesis testing. So hypothesis testing nothing but to confirm something whether it exists or not in your data set. And hypotheses have two types. One is for null hypothesis, that is the base case, or sometimes it is called due to chance, and another called alternative hypothesis, that is not due to chance or due to some extremities in the or due to a real effect. Okay, so here I will cover, instead of going for all the details that how the statistics works or something like that. I assume that you are in from research background, and you know at least such a small part of the statistics. And if you don't know, I will show at the end that what course you should take for that, and that is the best course, I guess, available in the Udemy. So I will start with loading the library. Here we are going to use the SciPy library, that is the scientific Python library for Python, and that could be useful for any kind of statistical computation and even as a statistical simulations. Okay, and next I will show the t-test, one sample t-test, two sample t-test, that is used to compare the mean of the two data sets or two columns, or is two columns, and paired t-test where the group is same, but we are giving something to change the effect and see whether the effect is real or not due to the change. Okay, and then I will show the Pearson chi-square independent test, that is the relationship whether two categorical variables are associated or not. Okay, then analysis of variance to compare the mean of multiple groups. And before that, we also show that the assumptions that need to be verified for ANOVA, that the data should be normally distributed using the Ggplot and self-readable test. And to a ANOVA, where we will also check whether within more than one group the mean varies more than for one group. Okay. Then Pearson correlation. The correlation is the it is usually measure the also a strength of association, whether a variable increases then other variable will increase or not, like that. For example, if the total bill is increases, whether the tip will increase, or whether total bill decrease, whether tip will decrease, like that. So it is known as covariance, and the strength is measured using the correlation coefficient, and that we will compute using the pandas and matplotlib. And also I will show that some categorical association metrics that is also available, because it is very difficult to measure using the correlation, though other types of correlations are available, like rank based. So we will here use the for Cramer's V and Telly's U. The Cramer's V is a symmetric association. That means like say I would like to see the association between day and time, whether day and time related or time or day are related. That could be same for whatever the coefficient you will get, that would be symmetrical, whether it is time versus you are associating the time with day or day with time. But in Telly's U, it is different. It is asymmetric association, because the day, whatever the day has association with time, the time might have different association with day. Okay, so that association also I will show with association metric library and Dython library. Okay, so resources, here is a book that is freely available. You can go to this link and also download this book. And you can put it if you would like to pay or donate something. If you would like to pay 0, then add this book. And this book has exceptional content for basic statistics and plots, different types of plot, which one is what. It's not about Python, but it is about basic statistics. It's written by mine and Joanna. Okay, these are two very good recognized person in the field of statistics. And next is Brandon Ford's YouTube channel. Everybody knows, I guess. It is the best YouTube channel available for learning statistics. Everything is available. Go to the playlist if you want to learn anything. It is here. Descriptive statistics, regression, logistic regression, multinomial regression, any type ANOVA with examples and figures. And next is, if you would like to go for a course, the Udemy has Mike Cohen's best course. That is, I recommend everyone to go through. With that has a code for Python as well as for MATLAB. Both is available. Okay, and it will show everything that is required for learning statistics that is useful for research work. And these links are added also in your IPython notebook. Okay, so this part is not required. I will directly import the NumPy as an NP. From scipy.stats, I will that scipy.stats I will import as SS, then pandas as PD, matplotlib.pyplot as PLT, and C1 as SNS. If I need the C1, that's why I'm importing that. Okay. So once the importing is done, then first I will start with the one sample t-test. This is usually used to compare whether a particular sample has a particular mean value, or whether the sample mean is less than that particular value or greater than that particular value. Okay, let's assume that whether our tip data set mean is equal to 3. I would like to confirm it. So the null hypothesis would be H0, the null hypothesis. That is our random chance due to chance that happens usually, and that is for due to the effect. Okay, H1 is the alternative hypothesis. So in null hypothesis, there is the assumption is that there is no significant mean difference. So the mean is equal to 3. And the alternative hypothesis is that the population mean is not equal to 3. So again, I'm saying that repeating this, that null hypothesis is that there is no significant mean difference in tip. The tip is equal to mu equal to 3, and the population mean is not and for alternative hypothesis, the population mean is not equal to 3. So first, after reading the data set, first I'm saving the tip from tips, the tip column dot values as an array. Okay, NumPy array. Dot values function automatically converted to a NumPy array. Then I'm saving the mu that I would like to compare in mu. Okay, and then I'm calling this scipy stats module SS. So it is as simple like this: ss.t-test1 sample, and then I'm giving the tip, that is the tip values, and the mu that would I like to compare. It will return the t statistics and p value, and I'm using a print statement to show that t value using the this format. Already we have learned that during Python lecture. So first, it's 3 decimal place, it will show the t value, and second, the p value with 3 decimal place, the p value. And again, I'm giving a test case because I know I want to print it as a hypothesis. Okay, so if our p value is less than 0.05, so 5% value, that is our alpha value, or sometimes called significance value, test significance. So we are setting it to 5%. Sometimes people set it to 1%, sometimes 10%. I usually work with pedestrians, so it is very difficult to estimate. So I take usually 10%. In physics, they need very accurate results, so they might need for 1%, even less. So alpha value set to 5%. So if the p value that is returned that is less than 0.05, then our alternative hypothesis will be accepted. That is the mean value differs from the given value. Okay, that is our 3. And if it is above 0.05, else condition, then no significant difference found. That is our null hypothesis. There is no significant mean difference in tip. So if I run that, it will give me the t value, and p value is 0.985. So it is above 0.05. So no significant difference found. So this one. Similarly, for 2 sample t-test, instead of comparing a particular value, we compare 2 set of data and try to see whether their mean are same or not. Okay, so So here I will use a data set. You don't have to go through all this, how I created this data set. Here I would like to compare that does the mean sex ratio differ between the two continents. The data it has like countries for a two continent. Here we will compare only, I guess, Asia and Europe. Okay, Asia and Europe, and they are the sex ratios values. Okay, and for different countries. So I would like to see whether the mean difference of the sex ratios are different for Asia and Europe. So what will be the hypothesis? H naught, the mean are equal, mu1 equal to mu2. That means our whatever the Asia and the Europe continent has similar mean for sex ratio. Okay, and then alternative hypothesis is that they are not equal, they are different. But what we don't know. It could be greater, it could be less. If you want to test that greater or less, then you have to divide the p-value by 2 and then check. Okay, so I have prepared the data. I'm not going through this thing, just to showcase how this test works. So it contains now Asia and Europe and all the countries and their sex ratio values. What t value and p value? That I won't able to explain here right now. You have to see by yourself. You have to learn for statistics. It is very difficult without knowing those things. They are the test at t value is the test statistics. Higher the value, more p value would be less, and p is the here the how extreme. If I search, how would I say that? So p value, if you type, the p-value is the evidence against the null hypothesis, that it is rejecting the null hypothesis. The smaller the p-value, the stronger the evidence that you should reject the null hypothesis. P-values are expressed as the it is not the exact answer. Statistical measure used to validate the hypothesis. It is actually how extreme certain observation will be. That is the case, but I'm not able to explain until unless you know the statistics. Basically, you have to first go through those courses, lectures, statistics. What is p-value will be defined here. I will not able to explain here because it will take so much time. And again, if I go for a statistical course, then it will take around 6 days. Even for machine learning, many people have requested that machine learning. Okay, so machine learning, even for teaching, it will take 6 days. How? 2 days to explain what is machine learning, what are the algorithms, then 2 days for implementation of the algorithms from scratch using the OOP method, class and attribute based methods, and then 2 days to implement in Python, and also in 1 day you will need the optimization part. So it is long journey. Okay, so it is not possible within one lecture. If you want to know what is p-value, you can go to the Brandon Folds lecture, and you have to see from the scratch. Don't rush. Okay, directly don't go for p-value. First know the descriptive statistics, then exploratory analysis, then confirmatory analysis. This is a confirmatory analysis because we are testing hypothesis. So step by step you have to go if you want to know the statistics. That course in Udemy, the link as given in this, that is the best course, but it will take 1 month. But you have to give the time, otherwise it is not possible. You have to make notes, you have to revise, there will be some assignments, you have to also fulfill those things. So learning process will take time. I haven't learned this in one day. Just I prepared that lecture in 1 day. To prepare that lecture, I have to know the content from scratch, and that took me around 4 years. So it will take time. Okay, just I will show here how it works. Okay, don't bother about right now what is p and t value. Just it is a hypothesis testing right now, whether the mean difference are there or not there, that we are comparing. Okay, so this is the data, and next I will also plot using the Plotline. So imported the Plotline. I also defined the figure size to show that how the sex ratios are distributed. So again, Ggplot the data set, then aesthetic. In the aesthetic, I'm giving the sex ratio. You can also give it here also with comma sex ratio. I'm giving in the aesthetic. Okay, it is I'm giving a different, okay, with plus sign. So it doesn't matter. You can also provide it inside that. If I don't want this, I would like this, you can also provide this. Okay, so here would be another bracket, and here I'm x-axis sex ratio, and I would like to plot the not x-axis, it is a y actually. So sex ratios and fill content based on the continent. So here the continent Asia and Europe. Okay, if you plot that, it will show how the densities are distributed, the sex ratios. Okay, over the values. And from that, you can't confirm whether their mean will be different or not. But it is a relatively good measure to see if it is a normally distributed or they are overlapping or not. That could be done. Okay. So next thing, first we have to separate it out the data for Europe and Asia. So Euro data, from Euro data, you can use the log. I am here direct using this thing. So you can use the log and here with comma, colon, and from that I'm taking the sex ratio column. Similarly, you can also do dot log. First one is for rows, and that I'm selecting here from EU data dot continent equal to Asia, and here for Europe. And here also you have to give a comma and colon. And I'm saving this to that I'm taking the sex ratio data for the Europe and sex ratio data for the Asia and saving in two different variables: Europe sex ratio, Asia sex ratio. Then SS, again I'm calling the stats module, and then t-test ind. Okay, and in that you have to give this two. Okay, these two saved columns, and then it will return t value and p value again, and the statistics are difference are same. So if you run this, it will show that the p value is 0.008. So no significant difference. Europe and Asia have different mean sex ratios. Okay, that is our alternative hypothesis. So Europe and Asia have mean sex ratio is different for different countries. Overall, like if I average, we will say. So next we'll go for paired t-test. Paired t-test is for when we would like to see the impact of something on the same observation. Like you want to see, say, if you have a land, you want to see that which fertilizer gives the better yield for the say rice crop. And you have first applied the first one, and then again applied the second one, and checked whether the yield is different or not, or whether the yield has improved in the second one. Similarly, you are here is an example. Say we have a 12 students. Yeah, they are given a first math test. We have the marks. Marks is out of 30. Then you have given a month of tuition to them, and second test was held, and you would like to check whether this give evidence that the students have benefited from the exam coaching. Okay, so same person, but first without and then with the particular coaching. Okay, and I would like to check whether the examination has improved or the mean is different right now. Okay, so same here, alpha value I'm defining 0.05. First test score are in a list I'm giving, and second score this the 12 score are there. Again, ss dot t test relation relative, I guess it is t test pairwise t-test calculated to related. Okay, related as a samples. So t-test related samples, because we are taking the observation for the same sample, same person, just for 2 times, one before and after giving the coaching. And again, the hypothesis will be the student have not benefited, null hypothesis, the student have not benefited from the tuition class, difference is 0, and alternative, the student have benefited from the tuition class. So mean is different, that means has changed. So the t value and p value is 0.09 greater than 0.05. So the student have not benefited from the tuition class. So the difference is nothing. You can also test like this thing. Significance of hypothesis, how to set it. Significance level, you are talking about 0.05 or something. It is also, I guess it has it like here it is also support that is I'm taking the two-sided value. You can take the less than or greater than, and also I think t-test SciPy test relational, and if you go to the documentation, then it will show the function what it takes. Alternative load p value, returns p value. Examples greater than 0. If the p value is smaller than, then reject the null hypothesis and equal average. I will check that if it is possible with this function or we need any other as a function. I will revert back to you. Okay, Lipsha, at the end of the lecture. Okay. Maybe it is possible. Maybe with other function it is possible. If it takes, will take the first look for that, and I will revert back to you. Okay. So next thing is Pearson's chi-square test of independence. Let's say you have two categorical columns. Let's say you have sex column and smoke column. Whether sex or smoke, sex and smokes are these two columns are related. We can use a Pearson chi-square test to identify that. The hypothesis is that here, the null hypothesis, the two variables are independent, and H1, the two variables are not independent. That means they are dependent or related. That is very much useful when you are modeling a, say, binary logistic regression or multinomial logistic regression, where you are predicting the categories, say some accident happened or not, someone died or lived, like these things. Okay, so yes, no conditions. Some the team won or lost, actually. That could be also tested. So at those cases, we have to even in journal you have to report the relationship of your independent variables and the dependent variable, that is the yes no condition, and whether they are related or not, whether they have any influence on that or not. Okay. And also you can check the pairwise such a comparison for your independent variables like x1, x2, x3, x4 in linear regression. That could be also sometimes required to report. Okay, so at that case, the null hypothesis is two variables are independent and alternative is two variables are not dependent, not independent. Okay, so for that, here I will test whether sex in the tips data set and day are related. That means I would like to check whether Sunday has more females are approaching the restaurant or males are approaching the restaurant, or there is a significant difference. You can also get the expected values because it is a chi-square test. So for that, I have to first create this pd.crosstab. Crosstab is a tabulation. It will tabulate the sex and the day column values like city. If you print, it will tabulate like this, that how many are female and for Friday, how many are female for Saturday. And this table you have to provide in the function. So ss.chi-square.contingency, here you have to provide this table city, and it will return you chi-square statistics, p-value, degree of freedom, and expected values. Sometimes we need also the expected values to see that whether there is a significance difference is there, and what would be the expected value should we require to get a significant effect. That could be also estimated using that. So I'm just returning the chi-square stat and p-value here, and same the testing part. If it is less than 0.05, the two variables are not independent. That or if it is more than that, two variables are independent. So here it shows the chi-square statistic this, and the p-value is 0.004. The two variables are not independent, so they are dependent. We have already shown that in Saturday female observations are there, or Sunday, like that. So you can also check that. The next thing is one-way ANOVA. So one-way ANOVA is we conduct when we have we would like to compare the mean for multiple variables. Okay. In t-test we have compared two, like for Europe and Asia, but let's say I would like to compare for Europe, Asia, and China. The mean, whether they are mean or difference or mean or same. So that could be a one-way ANOVA. And if you use a two sample as a t-test, like two variables, you are comparing the mean, and if you perform a one-way ANOVA, that will give the same result. Okay, so ANOVA basically used when we have multiple variables and we would like to compare the means. Okay, so the hypothesis will be the mean of the different groups are same, and H1, that alternative hypothesis will be at least one sample mean is not equal to the other or different. It might not be true that all the, if you have taken 5 countries or continents they are comparing, then every combination have to be different, at least one. Okay, that could be also done using ANOVA. So the question is, how does the weight of athlete, I have a data set called athlete, and that has different weight values. They have been weighted and their weight is recorded. So how does the weight of athlete vary between a team from different countries? So here we will compare 3 countries, China, France, and United States. We would like to see whether their mean are same or whether there is a mean are different for at least one combination. Okay, so I will not go how I have prepared that data. You can also go in your spare time. So team that contains France, United States, and China. I think also yes, China, and their weight corresponding weight values. Okay, and team, this is for team member observation for each player. Okay, the player 82 observation is for particular player who is from United States, having he has a weight of around 61 kg. let's say it is in lbs or kg in some unit. Just consider like that. Okay, right now. And if we plot that using the our Plotline, now you can see that from median you can't say which one is significantly different. But when you do statistical hypothesis test, what this SciPy library does, it resample, combine all the data and take sample from the data with a replacement. That means the same sample could be taken twice and put into different categories, like whether it is for China, whether it's and this thing it can done 10,000 times and try to check whether whatever the current data set we have, whether the mean is greater than from that or less than from that, and how percent. But that gives us the p-value actually. That could be done using resampling technique, and that resampling technique it usually uses to simulate the p-value or to calculate the p-value. So the condition for ANOVA, that here we are trying to see the difference between the weight of the different countries between countries. So weight is the continuous data. So whenever you would like to apply the ANOVA, the first condition you have to check it should follow a normal distribution. That is the condition. So again, for athlete weight, I have already showed you the Ggplot. I will directly plot and it will show the Ggplot. Now you can see that it is for stats normal. It is not normally distributed. Assuming that it is normally distributed, I will show the next things. But if it is not normally distributed, then the ANOVA is a parametric test. So you have to go for non-parametric test, where the assumption is not required that it has to be normally distributed. Okay. So assuming that it is normally distributed, I just show you. Okay, but it is wrong. So whenever you do your actual research, you have to test it. Otherwise, you are not able to apply ANOVA. For that, non-parametric test exists that doesn't require this assumption that the dependent variable has to be normally distributed. And the separable test is one of the also test. This is a graphical test, and if you want a hypothesis test, the separable test is commonly used. I have also reported in my journals. So hypothesis, the H0 will be sample is from the normal distribution, and H1, that is alternative hypothesis, will be sample is not from the normal distribution. Okay, so again, it will return us the statistics and p-value, and the function is Safiro that I'm taking from the stats module. Okay, so rather than doing this, so SS, we are importing this SS, then dot. Okay, so scipy.stats we have already imported as SS, so I don't have to mention it. So SS.Safiro and athletes weight column, and it will return a statistics and p-value, And again, I have also given the condition. It will show the statistics and p-value is 0.000. Sample is not from the normal distribution. Actually, it is not from normal distribution. See. So assuming that it is normally distributed, right now we will perform an ANOVA test to see whether the mean differs between the countries athletes. Okay, like France athlete, US athlete, and China. So what I did actually taken the athlete data set, and with log I identified the France data, the team where the team is France, and taken out the weight column and saved in France athlete. Similarly for US, similar for China. So SS, again, we are importing the SciPy library F one way, that is ANOVA one way. Then France data, US data, China data. It will return a statistics and p-value. And again, I have given a condition. So if I print that, it will show me the statistics, the p is 0.000. Significant difference exists between the weight of athletes for each country. So at least one difference exists between two pair. Okay. So for two-way ANOVA case, same we have to check the normally distribution criteria, but here it is not satisfied. I'm assuming it is a normal distribution. And next we will try to see. Now we would like to compare two categories. Instead of just team, I also would like to check whether the sex, the weight is different, mean weight is different for the sex. Okay, across the country. So here again, I've loaded the Olympic data, and I have the data set right now. And if I plot the weight and giving a fill color of sex, so it will show, I would like to compare only two, China and United States, the two team, and also the sex category between male and female. Okay, so you can see that the male has almost higher weight compared to the female in every case, but within the that is within the country, and between the country also little bit similar, but it could be different because it is just showing our based on sample. But if we take resample and plot several times, then we'll get the confidence interval. Okay, so fitting a two-way ANOVA. So for that, we need to use the stats modules. So from import stats module as SM, and from stats module dot formula dot API, because we will use a formula like R syntax. So import OLS, ordinary list square, because we are predicting, we'll predict the continuous data, that is our weight, and our independent variable will be sex and team. So the formula I have created here, we would like to predict weight. That is the R syntax. Okay, it also support R syntax, the stats model. So weight is predicted by sex plus team. These both are categorical data and or contains strings. So we have imported the OLS. So OLS, inside that we have given the formula, data is equal to athlete, and dot fit method we have to call to fit the model. That is our OLS model, ordinary least square or linear regression model, multiple linear regression model. Then what we have to do, we have save the model in the this model variable. And right now we will take from SM API.stats ANOVA linear model. And inside that we have to give that model to check for ANOVA test. And here we have given type 2. And if I print the table, it will show that the p value is less than 0.05 for this sex. Okay, and for team it is such a not less than that. So according to the result of the ANOVA, mean is different for sex but not across team. Okay, same way more category you can add. So currently I will we will take how much time is, we'll take 5-minute break, then we will start with the correlation part, and this will take around 15 to 20 minutes. Okay, so if you have any question you can post. If you want to learn statistics, then go for the Brandon Folds lectures. Then Stammer's lectures are also there. Josh Stammer, that has already given a lecture in IIT Guwahati last year, I guess. He has given a lecture in IIT Guwahati. So Josh Stammer's lectures are also good, but it is a little bit advanced for machine learning part. And you can go for that book. You can download it for free just to learn the statistics. And if you want to learn for Python or using the Python and also the MATLAB, then that Udemy course is more than enough. That Udemy course is more than enough. It will give you everything, whatever the statistical test, relationship, linear models, logistic regression, then ANOVA, how it is done, what is the equation behind that, everything is there. You'll get it. So we will start at 12:40. Okay. So I will resume this lecture right now. It is 12:40, and I will look into your problem, but I need the data. Okay, so after end of this of today's today's session, you can send the snapshot of the data, whether it contains categorical data, numeric data. That I have to look first. Then I will suggest whether anything is available, because I never done that. So if it is possible, then I will send you the test that you would like to you need to perform. I hope I'm audible and my screen is visible. Please write in the chat box if it's clear or not. Then I will proceed with the correlation part. Is it? My screen is properly visible, I guess, and sound is clear. Anyone in the chat box, please? Yes. Okay. Then I will proceed with the correlation part. The correlation is nothing but the association between two numerical variables. Okay, it could be a ranked variable that have a specific order. It could be uh, uh, normal variables like that doesn't have any order. Like here, I will show you using a concrete data set that is from uh, not civil engineering department, but it's taken from some place. Some professor has uploaded that data and make it open to all. So I have taken that data set to show you that it contains all the numerical variables, and that I will show that the correlation estimation process. So why this we need the correlation estimation? Because when you fit any kind of regression model, the assumption is there the variables are independent. If your variables are dependent on each other, like say this cement or slag, the content is related to each other, then it will influence the estimation process of your coefficient, and you will get a biased estimate of the coefficients. Okay. So in basic cases, every journal, if you see where people use linear regression or multiple linear regression or logistic regression, multinomial logistic regression, any type of regression, they usually perform this correlation task beforehand. If your data contains numerical data. Okay. If it doesn't contain numerical data or some rank-based data like 1, 2, 3 for ranking or something, then also methods are there. So for Pearson correlation, we need the numerical variables that doesn't have a specific order, like it could be random 540, 50 like this, it will appear for each observation. Let's go for the concrete data set that contains these columns: cement, slag, content. Slag is then ash, water, superplasticizers, I guess, and coarse aggregate, fine aggregate, age, and the strength of the concrete in MPa, I guess it is, or some unit. So how will compute the correlation? Just you have to take the data set, then use the dot core method for pandas, and then method you have to supply the Pearson. Other methods are also available, like Kendall's tau coefficient is also available. Then Spearman, the rank-based correlation also available. Okay, so here it has no rank, assuming that we are using the Pearson correlation, and I'm also rounding it to 2 decimal place. And if I press Control Enter, then it will plot. It will give return the correlations. The correlation ranges from -1 to +1. Okay, the -1 means perfect negative correlation. That means when one variable decreases, the other variable also decreases. The negative means, and positive means when one variable increases, the other variable also increases. Okay, and positive one means perfect positive correlation, that increase. Okay, so here you could see that like superplasticizer and water has negative correlation. Like that means yeah, if you increase the content of the superplastic plus water content, then if I go for a strength, that would be much better. Like for cement and strength. For cement and strength, it will make much sense. If you increase the cement content, the strength will increase positive. And say for water and strength, it is 0.29. So as much as you water, after a certain content, the threshold limit is there. After that, if you add more and more water, it will reduce the strength. Okay, so that's why it is negatively related. That one increases, so other is decreases. I was a little bit wrong. So one increases, other is decreases. Okay, so let me show. Sometimes I also forget these things. So positive correlation. There that could be on plot. We could take it this one. This is a perfect positive correlation that one increases and other increasing. And negative correlation, one increasing, but another is like for this one, the value is more, but this one for value is less. One increases, the another will decrease, and no correlation. There is no relationship. Okay. So that means when both are positively associated and one is increasing but other is decreasing, I guess. So negatively it's related, and no correlation. Okay. So like for this value, if I zoom it a little bit, it will open. I guess. So if this value is this increases, like this line will show that once this value increases, this value also increases. Okay, and the negative shows as uh, uh, this value is decreases like this one. For this one, it is high, and this one is low. Okay, so negatively related means one increases, another decreases. Okay, so the relationship is negative, directional. Like this value is high, but for this axis, y-axis, this is low. And for smaller values, this value is high, but this value is also high, sometimes low. So yes, I little bit get confused sometimes also because so many things are going on. Yeah, the negative correlation when one increase and another will decrease. Okay, so confusion happens still. Okay, so negative correlation means one will increase, another will decrease. Like if x increases, y decreases. Yes, thank you, Devendra. Okay, so we have computed this correlations, and then we would like to plot it using a matplotlib function. So the figure and axis object is, we have to create this figure and axis object. We have saved the data in correlation.df, and we use the Pearson method. And next, the plotting the values. So for axis object also contains the IAMShow method. So axis.IAMShow, that is for showing the image of say with a color gradient. Okay, so it is usually used for showing the images, but we will use to show a gradient of colors and the values, to impose the values. Okay, so that takes the correlation df.values, the values we have in this data frame, and we will also interpolate to nearest so that it will give us a color bar that is have a gradient of automatically interpolated gradient, so it will be smooth. So color map, I will choose blue. That is an internal color maps are available, like reds, blues, different as there, and it's and minimum v minimum and maximum we can also define here. It should be from -1. I guess I made it wrong, so if you can correct it, because it is a linear regression. Let me plot it. Okay, yes, -1 to +1. So it is wrong here. Please correct it. It's not from 0 to 1. I have taken the code from, I guess, Grammarsby. That's why it is 0 to 1. So -1 to +1. Okay. So that would be the range that this color bar will be plotted. And then I have to give the tick level. So first in x-axis tick level I have to set. So axis dot set x ticks. Then ticks equal to range, whatever the column we have, length of the number of columns. And then labels are the columns such as name from concrete.columns. Similarly for y-axis ticks, that would be same because it is symmetric. And then we have to give the tick parameters. That x-axis level size should be 12, rotation will be 90, and y-axis tick parameters will be in y-axis level 12, level size, and rotation will be 0. Then what we'll have to do, we have to call the figure object. Then inside that we have the color bar, and inside that we have to give the CAX, that is our image. And after that also dot axis dot tick parameters, and I would like to change the values of this bar. This need to be, I need to be more zoomed out so that I increase the size to 12. Next, coming to the annotation part, how I would add these values. That requires another function from NumPy that is called NumPy.end enumerate actually. Okay, and that means n-dimensional enumerate. So earlier we have shown that enumerate, what it returns. It returns the index value and the values. Here it will return the xy values and the value, xy coordinate and the value. Okay, so Once we loop through our data set, it will return us xy and the t value. That is our value of the correlation on that plot. Okay, and that we will try to annotate. I have already showed you the annotated version, access.annotate. So using the format function, inside that I'm first giving the value at 0.2f, that is floating point 2 decimal, and it will add the t, that is our values. Then xy coordinate should be in a tuple that return xy. So xy, and vertical alignment would be center and horizontal alignment should be center. Then I've also used the color to set the color. So set the color to black. If you would like, it could be white, and size is 12. If that means it will iterate through each coordinate values and the value associated with the this table, and it will plot and annotate at that position on the figure. So now it is white color. Okay. So that way it will provide -1 to +1, the gradient, and also the different values. Okay. So perfect correlation is 1, and somewhere it is positive, somewhere it is negative. It is just for illustration purpose. Okay. So that way you can directly plot it or provide in your journal or thesis or in your wherever you want. And if you want to save, again the figure of we have the figure object, figure.savefig, and you can provide the image location, DPI 300, bbox inches. It will remove the outer spaces and tight. So it will save that. Okay. Next, the plot Pearson correlation coefficient. What we have done here with this much customization, that could be done in one line with this library. So you have to install that library. Okay. So how you would install that library? Same conda method or pip. So I have already installed that. So from dython.nominal input association. Okay. So hello. Let's keep the color black for better visibility. Okay. So you can set that. It's black right now. And it is a little bit blurred because it is showing the low resolution one. Okay. Previous examples. Okay, this one. I've already done that. And it's showing a little bit blurred because whenever matplotlib plot, it will reduce the resolution. So whatever the saved one, if you get the correlation plot, it will look like very sharp. If you also increase the resolution to DPI 400, 600, it will do that. Okay. So next thing is using the dython library. So first we are importing the dython.nominal and association. Okay. And then it automatically detects you are giving a continuous data. So association here, it is also provided with nominal to nominal association. If you don't like the numerical columns, also could be given if you want to give only the numerical columns. So it automatically background detected that I'm giving the numerical data. So it automatically compute the Pearson correlation. Okay. So figure and axis object again, then association inside that concrete data set, axis equal to axis, C map, that the color map equal to blues. And I'm saving again in that way. And if I add enter, it will give us the plot. And here you can see the range from -1 to +1. And these are the values. Same in one line, you can plot. Okay. Next thing, it also returns some values. One is the correlation matrix, because once you're giving this data directly, concrete data, you are not giving a correlation matrix here. Like in the earlier, we have given the correlation value that saved correlation matrix. Here in background, it is calculated. So if you using this library, you might want to tweak it, this correlation value, or you might want to take the values and compare with something. So this, I'm saving this as a R. So this R contains the correlation coefficients also. If you take out, index out this core and round it, it will give us the same that we achieved using the pandas. So next thing is that when you have nominal variables, which has no order actually, categorical variables. Say you would like to check the association between day and sex in the data set. Or you have, say, in our cases, sometimes we would like to say, sometimes I calculate the signal violation, whether someone will violate the signal or not. And I would like to see the association with the age, with the signal violation, or sex, like male, female. with a signal violation tendency. That signal violation is a categorical binary data. Similarly, age could have multiple categories. So sometimes we like to also see whether there is an association between categorical data. But this categorical data association is not cannot be computed, and would be erroneous if you compute using, say, a rank-based correlation or Pearson correlation. Okay. Gathered this information that Cramer's V and tells you there are two metrics which could be used to identify. What is this matrix? You can read in the internet. Plenty of resources are available. So Cramer's V is a association for nominal variables. The Cramer's V is symmetrical measure of association. What means symmetrical? I will show. The value range from 0 to 1. 0 means no association. 1 means perfect association. Okay. So no positive or negative association because it is a categorical data. But what is the association? 0 means no association. 1 means perfect association. So I would load the tips data set again, and here what I will do, I will use the association matrix library. So first I will show you with this, then I will show you the Dython library. Okay, what is the time? 12:56. Okay, so import the association as AM. Okay, and we have given a nickname and imported it rather than typing this much. I'm importing as AM. Light came in the hostel. Yes, it is there. 9:20 it came actually. I'm taking the lecture from hostel only, Lohit hostel. So next, what we have to do, the association matrix library needs to be needs all the categorical data to be converted to a category type. So what I will do, I will use the apply function. I have shown that apply function to apply particular function, and here I will use the lambda function, lambda x as dot category. If the x dot type equal to O, that is our object category, that is a categorical variable, then return x dot as type category, convert it to category and return in the tips data set, and we will save as df. Else return x. If it is numeric, then return only x. Okay, so whatever the categorical variables, object variables, that will change to category, and that it easily required for association metric library. Then how to calculate that? Then am dot Cramer's v, that is the function, and inside that you have to give the data. It automatically identifies which one is the categorical variables. Next. Next, we have to fit. We have already added this in the Cramer's function, and we have got the object. Then with object, we have to apply the fit function and round it up to 2, and we are saving in the C fit. So it will give us the value. That diagonal one is showing 1 because it is perfect relationship with sex or smoker with smoker. And this is a symmetric association. Why? Because day and sex here you can see it is 0.23. And sex and day also here is a 0.23. Because in upper triangle and lower triangle values are same. Whether you compare sex with day or day with sex, it is same. But this is sometimes very odd because the sequence in which the data are in a column, that is not in a similar way. We cannot say that how the sex and day are related, and day will be related with sex same way. So that's why we also estimate the Telesio coefficient. So first I will plot this similar method that I have already discussed. First figure an axis object, then IAM show method where we will provide the C feed values, interpolate the blue, and now the mean value 0, minimum value, and maximum value 1. And again this range fixing of the tick labels, then parameter fixing, then color bar adding and adding the values. So if I run that, it will show me this plot from 0 to 1. Okay, now you can see from the visualization day and sex is related, the association is 0.3. Even sex and day also 0.3. But this is not the case. Sometimes it is odd vary because it is categorical data, the sequencing system is different. So we can save this data. Next, I will show you the Dython library. So again, we are importing the association from the Dython.nominal, reading the tips data set, then axis and figure object. Then inside the association, I'm providing the only categorical column data. So from tips, I'm taking out the sex, smoker, day, and time. I would like to only compare those. Then nominal to nominal association. What would be the nominal to nominal association? It should be Cramer because they are the nominal data. Then axis equal to axis, CMAP is blue, and it will plot the same thing with just white. You can also change because we will get the axis object. So now you can also, we have saved this output to Cramer's. So Cramer's also contain the correlation coefficients. So you can also plot that. You can also get the axis object in this if you call the dot axis. Okay, so you can also change the things, like if you would like to change the color, value, anything, because you have that axis object. The next thing is a pairwise correlation for nominal data, but it is not a symmetric association. Okay, it's a asymmetric association. Correlation of xy is not, the association of xy is not equal to association of yx. Okay, how the day is related to sex is not equal to sex is related to day. Okay, so sometimes it is also reported, and it is the best matrix, because the symmetric one, it's a little bit doubtful. I always think it is a little bit doubtful, and this is the best one. And it is also ranges from 0 to 1. 0 means no association, 1 means perfect association. And same way, we will use the association library from the Python, and we will load the data, figure an axis object, then associations, tips. In the tips, we have to give the tips and columns that are categorical columns or object column. Okay, then nominal to nominal association. Now here we have to write tail. Okay, so he has proposed that was a coefficient, and x is equal to axis, C map equal to blues. It will return the plot. Now if I look to the association, like say for day is associated with smoker by 0.04. Okay, but smoker associated with day is 0.08. They are not same coefficient. Okay, they are different. Some places it is same, but some places it is different. Like for day and sex, 0.2. Then sex and day is 0.04. Okay, 0.02 and 0.04. That is different. And that is sometimes very useful, that one categorical variable, how associated with other, and other way around could be different. And same way, it will also return the, if we have saved that, if you save this in tells you I have saved this in variable, and if you index out the correlation matrix, you can also get the correlation matrix, and also it return the axis object. So you can also manipulate. If you like to just compute from this function, but you want to take out the correlation matrix, this pandas data frame, and then you can directly use this function to manipulate many things, because you have the axis objects and also you have the correlation matrix. You are getting from the both way you can do. You can use that association library or Python. Any way it is possible. I hope it is clear how these correlation matrices are calculated and how this can be plotted with just one line of code using Python library. Okay, just one line. So if you have any questions, you can post. Otherwise, we will go for the break, and we will resume the lecture at 3 o'clock, 3 p.m. Any questions regarding the lecture? The statistics is very vast. Even I can't remember something. Like say I right now made a mistake that what is the negative correlation looks like. I haven't used it for say 3-5 months. So I forgot. If you don't practice it, it will slowly diminish from your brain actually. Okay, so I know this way it's computed. Then I forgot the small part, that it is one increases, another increases, one increases, another decreases. So it comes with practice and how frequently you are using. You can't remember everything. You have to take note, and somewhere you have to keep those things, and whenever it is required, take out those things and apply. That is the learning process. Okay. So if you have any questions, you can post in the comment box. I will try to answer that. Else we will close this session for right now, and we will resume it at 3 o'clock. Any question? I'll wait for 2 minutes. If there is no question, then we will resume at. You can join at 3 o'clock, and this will be a lunch break for 2 hours. Nice question. I hope I think no one has any doubt. In the next session, we will start the machine learning part. give an introduction. What is supervised, unsupervised learning, different types of regression and classification methods, and little bit I will show that how to fit a multiple linear regression model using Python using the stats model package, and also Durgesh sir will show that how to train a classification model, like when we would like to predict no, yes, or multinomial cases, that could be also possible. And this is a very big field, that machine learning. That's why it is not possible to cover everything in one day. It would require like this 6 days or 3 week again to teach it in detailed manner actually. So we'll just give you the basic introduction. Okay. So it would not be that much detail. If you need resources, we can provide the resources. Then we will resume the session at 3 o'clock. If you have any question, you can post it in the chat box. And right now I'm closing. Okay, so you can go for lunch, take rest, and rejoin at 3 o'clock.